Okay, a function is increasing if f of c is bigger than or equal to f of, I don't want to say f of c, f of x is bigger than f of c. What? A function is increasing if. I'm going to say it like we would say it in class. The y values are getting bigger. Yeah? So what we're saying here is, and I wanted to look the exact wording up in the book so I'm not a stupid idiot. I know what I want to say, I just don't want to say it wrong. Oh. What I'm saying is f of x2 is bigger than f of x1 if x2 is bigger than x1. Its y values are bigger than its y values just before it. That's what increasing means. It's climbing. It's going up. Right? Mathematically, we say the function's y value at x2 is bigger than its function's y value at x1 if x2 is to the right of x1. So here's x1 f of x1, and to the right of it we've got x2 f of x2. We would say it is increasing there because the y values are bigger, right? One of those duh moments. Okay. Another way to test for increasingness is f prime of x. What is the slope, my friends? Climbing or falling. For increasing, f prime of x is bigger than 0. So do you want to? So we got two ways to determine if things are increasing or not. Are the y values getting bigger, or is the slope bigger than 0? Okay, what's decreasing? A function is decreasing if f of x2 is less than f of x1 when, or if x2 is to the right of x1. Or, if you're lazy like me, and I don't want to do all that work, f prime of x is less than 0. Slope is negative, Mr. F. Okay. Horizontal tangent, HT. So, where's the function y equals x squared increasing and where is it decreasing? Well, really what I want you to do is to find the derivative. What's the derivative? 2x. So I want you to solve this equation for increasing and this equation for decreasing. Mr. Up, this isn't hard, I hope. Would you agree that this isn't difficult? Okay, now I don't actually do it this way. This is too much work. This might seem like more work, but it's not. The first thing we need to do is find the critical point, CP. 2x equals 0, therefore x equals 0. You're looking at me going, what is this? I'll explain what I'm doing in a second. So what I'm going to do is I'm going to break up the function's domain into two regions. A region to the left of the critical point and a region to the right of the critical point. Where does this function's domain start? Y equals x squared has a domain of all real numbers. Where does this function's domain start? Negative infinity. Where does it finish? So I'm breaking my number line up into negative infinity to 0 and 0 to positive infinity. So I would like everybody to take the derivative and pick a number between negative infinity and 0. Pick any number you want between negative infinity and 0. Any number you want. Any number. -1. Okay, very safe number to pick. Substitute that into the derivative. Put -1 in for x. What do you get? -2. That is a negative amount, Mr. App. That means the function is decreasing. Pick a number between 0 and positive infinity. E. 2 times e is a positive number. It is increasing over that interval. And at 0, it's a critical point, silly. I just do this. I just pick numbers. This process is called sign analysis. It's easy. All you got to do is find the critical points. You know how to do that. Find the critical points. F prime of x equals. Good. Make it equal 0. Don't be lazy. You just got caught. What does x equal? Plus or minus 2. You just got caught when you said 2, right? Okay. So we're going to break our function up into 3 regions. We're going to start on the left. What just happened? Where is it? Start on the left. What's the lowest function gets in the x values? Negative infinity. If it had a root, it would just start at that point. Yeah, so negative infinity, we're going to go to our first critical point. As we go along the number line, which is the first critical point we meet? -2. Then we go to our next critical point. And then we go on to the endpoint of our domain, positive infinity. Now, I got these ones. These ones are freebies. These are critical points. Yes? Okay. Everybody pick a number between negative infinity and negative 2. Negative 7 million. 3 times negative 7 million squared minus 12. Is that answer positive or negative? Positive. Increasing. Everybody pick a number between negative 2 and positive 2. 1/72. Into the derivative. Into the derivative. Into the derivative. The derivative is positive. The derivative is something. The derivative is something. Okay, so pick a number between negative 2 and positive 2. What number do you really think I could pick? Really? I'm lazier than that. 0. 3 times 0 squared minus 12 is negative. So it's decreasing here. And then pick a number between 2 and infinity. Good. Positive. Increasing. Sure, you know that. But I can make it decrease again. I can make it go increasing, decreasing, decreasing with some functions. No, you do not assume. Do not assume. If it's a polynomial, it'll go increase. No. Oh, I can make polynomials go decreasing, increasing, increasing, decreasing. And you would not like me. So do not assume. Okay? It will change. You can go increasing, increasing, decreasing, decreasing. I can draw functions that have that property. Okay? So, you just need to be careful. Okay, flip the page. Is that it? Okay, so that's it for today. What do you need to do? You need to give me that assignment. So if you haven't finished that assignment and turned it into me, you need to be making sure that that is done, and I am happy with it. I will hopefully give it back to you before you write your test. You need to come in the morning and get it from me. It'll be in the Christmas box. If you've already turned it in, it's already in the Christmas box ready for you to take back. Okay. I will attempt to mark them in F block, next block.